Hello everyone. At 2013, I joined a company called MRSys. That was a really strange company. So from one part, they practiced pair programming, which I really liked. They also wrote a lot of tests. So they wrote a test almost to everything, which I loved. But they also committed to the main branch. They didn't use any branches, feature branches. They didn't use pull requests. They didn't open, they didn't review this. So it seemed to be super reckless, for me at least, because I'm really a quality obsessed person. So I had my doubts, but it worked out well because I just realized that they were not really reckless. They were safer, they were faster, they delivered fast. They had fewer moments when someone was afraid to push the deploy button. So basically, it was an amazing thing, and they wrote the best code that I've ever seen. And it worked when I joined, and there were 40 developers at that company. And while we scaled up the company to 130 developers, it still worked. And we had 40 to 50 deployments to the production every day, without any hassle, without processes, without heroism. That was really a daily routine. And what they did was continuous delivery. And today, I know that the world just changed a little bit, not a little bit, a lot with the era of AI, but I see we have the same problems. We really have the same problems that we had back then, and I think the answers are also the same what we use to scale our engineering culture. So, hello everyone, I am András Fincza, or Draven, how most of the people call me. I spent almost all my career around or with extreme programming and continuous delivery. I practiced it as a developer, and I scaled it as an engineering manager and later as SVP of engineering at MRSys. Today, I'm a tech lead at Xund. This is a small health tech company. We are building a kind of a AI general practitioner, and this software is certified as a medical device, which is like a pacemaker. So you can imagine how much compliance, regulations, and audits we have. Just today, we had one audit. So when I talk about delivery, I don't just say these common SaaS things like, okay, with a wrong delivery, a button was on a wrong place, but sometimes people's health depend on us, so this is really important. But with all these constraints, we could really reduce the time to deploy to production from months, from half year, to basically any time, and also we do it regularly every few days. And not because we are less careful now, but because we are more disciplined and we have a better harness around the delivery process. Let me show you the normal delivery lifecycle. So that's nothing new here. You start developing something, you do the implementation. When you finish the implementation, you do the verification, pull requests, and everything else with this, and then you release it. But today, we have a new pressure. Now that people have plenty of AI agents on their hands. Every developer has their own small AI teams. We have more code, we have more pull requests, we have more changes, we have all these things faster. Everything is way faster than before, and it seems that now we generate a lot, but all the things around delivery, trust and efficiency, that did not magically scale with the output what we can do now. These are numbers from Pharos, a company called Pharos. They did a large study. They asked 22,000 developers from across 4,000 companies, and they found out that on these companies, while they adapted the AI, these are the slowness what they suffered. So as you can see, for example, the time spent in a pull request in review went up with more than 400%. The lead time, so to just commit to production something, the time goes up almost 5 times. That's really huge. It seems that everything slowed down with AI. But here is what really happened. AI increased the generation speed, but the rest of the delivery system remained human scale. AI did not break the delivery. AI just made delivery problems visible. If your system is healthy, then AI make it fast. If your system is fragile, then AI will break it apart. And these are the problems, not with the AI and not how we started to use AI, but this is a problem of your harness you built around the system for delivery. And these are not new problems, because with big batches, with overloaded reviewers, with fragile pipelines, with too much waiting on human oversight, quality checks, doing quality checks too late, and now even with CI systems slowing down, because if you just look at some blog posts from GitHub, it seems that they are really struggling with the increased load of their CI systems. So with all of these problems, this is not new. And every one of these problems are something what continuous delivery solved 20 years ago, maybe except the last one. So what this MRC team 20 or 13 years ago really did? What we built was a harness. We didn't know this word before. I just realized it now, that we called it extreme programming. We called it continuous delivery. Because what is a harness? A harness is the same thing like these. The safety around changes we make. It guides you, it holds you, it makes you fast and try to save you from falling off the cliff. The harness of delivery is the sum of all the disciplines, automations, AI, agent skills, and everything we use to speed up and make the delivery safe. And here is the good news. The reason why most companies didn't adopt continuous delivery is that it's not easy. If you tried it, if your company tried that, you know that there are a lot of practices which are arguable. This is really a set of very hard things which needs very strict disciplines from the engineers. But today, with AI, we can automate a lot of things. AI can help to keep this discipline. So for the rest of the talk, I will go through this timeline. I will go through the software development lifecycle and show you how you can optimize it, how you can change it to deliver faster. The first two things which I will show you will shape the figure of this timeline. All the other ones will optimize a few parts. And the very first one is about batch size, which will define the length of this timeline, how much work we want to implement and deploy in one cycle. For that, let me show you how it looks like when things got wrong. So we use large batches. At some point, I don't know, that was very long ago now, maybe 10 years ago, at Emarsis we hired a very well-known agency to build the SMS service for us. We made the marketing software, we sent out millions of emails every day, but our customers really wanted to have transactional SMS sending, like registration messages, like 2FA messages, and so on. And the agency just developed it. That was great. There was no problem with that, but for the first. But then, by time I mean a few months, I started to struggle on load. And when, for example, someone's 2FA message just got delayed, then you don't hear usually from them that, hey, this is a nice distributed system challenge. They usually say that, dude, your product is broken. So with that, this agency promised us that they will fix that. And they started to fix that. They said that will be small. We just introduced some asynchronous processing here and there. We introduced some message queues. It took them 1 month and 500 commits because obviously they had some issues along the way. And then they wanted to just deploy it at once. Yeah, this is a common disaster story, so nothing new in that. You know, when you are on the top of a mountain and you just throw a pebble down, usually that won't cause any problem. If you throw a rock, then it may destroy some houses. But what they build a mountain and just throw it to our production system. obviously didn't work out. So first disaster, we need to roll back, and then I jumped in. And for one long week, we tried all day to just release their stuff. And every day we released, rolled back, fixed, and so on. It cost a lot, not just money, but customer pain as well. And then I said, okay, guys, we just let it go. we won't deploy it. So we canceled this refactor and brought the full project in-house. And they were good professionals, so that was not a problem, but they chose the wrong delivery model. Their feedback came too late. This is why this example is one of my favorite one, which assured me that why continuous delivery is very important. And the reason is for that continuous delivery has one claim, the one important claim, that small, frequent, low-risk changes are the only honest way to be both fast and safe. And small changes just shrink the entire life cycle. So it happens because everything just gets smaller. So if you won't try to develop deploy, integrate one large feature at once, then things are easier. And this is not just my opinion. There is a great book I suggest you to read called Accelerate from Nicole Forsgren and Jess Humble. And they found the same conclusion with doing a survey they also did with more than 20,000 developers across thousands of companies. And they also found that the best teams are faster and safer at the same time while doing smaller batches. And that agency I mentioned, you worked 1 month and they had these 500 commits which they wanted to throw to us. But currently an AI agent can do it for you next Tuesday or something like that. So that means that small batches are no longer just a hygiene problem. These are really, small batches are really the leash you put on the AI to be able to deliver. And I know it's very hard when you use AI because it seems to be capable to anything. So usually you put a full epic, stories to them, features from A to Z, because it seems to work. But this is how you end up with thousands of lines of changes, which is really hard to manage, really hard to review, really hard to integrate to the system. So you must force the agents, you must force yourself to make smaller changes, save steps, and integrate one by one into production. The same way how continuous delivery did with us at MRSys. There is no magic here because you say the agent what to do. It's up to you how small is the task you choose. You can split the work. Okay, this is also something which changes the shape. These are the feature flags. The flags are mostly, so it's a really common thing. It's like an if statement, a conditional, very easy stuff, but it does something important. It splits the release to deploy and release. And it's really important because deployment means that you put some stuff into production. Release means that it can be seen by the user. And these two milestones are not the same anymore. And with that, it changes a lot of things. Look at the life cycle now. So instead of one very risky thing we called release, now we have multiple calm milestones. You can really just put some unfinished work into production anytime because it won't be seen by anyone because by default the feature flags are switched off. You can give it to a few customers if you want to pilot some features, you can test it out. And if there is an issue, you can just turn it off. And instead of having a very complex rollback, for example, if you want to have a rollback and you had some DB migrations, then the complexity of rollback can really explode. Yes, so this is why it's really important, but flags do have their own costs. And I think the most important cost is the maintenance one, because usually feature flags stay in the code forever. This is a very common problem. I saw it in many companies. And for years, that was one of the most boring jobs for a developer, to just obsolete feature flags, remove it, and maintain the code, rewrite all the tests, and so on. At Emarsis, we organized kind of a hackathons to everyone jumped in and for 2 days deleted feature flags and so on. So that was a thing, very boring. This is why one of the first AI skills and agents what I wrote was to remove feature flags. So I just created this command, remove feature flag. I put a feature flag name to that, and then the agent just starts to remove that and rewrite all the tests, keeps the live code path, deletes everything which is not needed and try out. Obviously, it also checks via, we are using config-cat, which we will hear soon. We use their MCP, so it checks that this feature flag is already released to all the environments. So we want to delete something which is not enabled in all environments, and it works pretty well. So for human, it was a super annoying cost, but for the AI, it's almost nothing. So next one, small batches and feature flags reshaped the lifecycle. Now we go to the optimization path. So we will optimize these 3 parts. The first thing are the tests, but not just more tests, better tests. Basically, it's less tests, but better. This is the important thing. Look at an example. Look at an example, a bad example first. Yes, this is a test. This is a lot of code, and you don't understand, which is great, because that was the reason for this example. Things are happening here. So you see that things are mocked out. There is a user repository, so it probably tries to just mock out the database. It uses this library. I don't know if you know, this is a real library for password strength meter. I don't want to spell it out. It's also mock it out and so on. So it tests everything. This is a classic unit test. And from that as well, that you don't understand the name of the test. This is a unit test written to an implementation. It's really a lonely test. We call it a solitary test. I don't want to go deep why it's bad. I want to show you a better example. The same thing from another perspective. This is a sociable test. Sociable test doesn't mock out anything. It uses database. It uses the integrations. It hides this strange library behind that. It tests behavior and not implementation. And this is that kind of test which I like more. Now you can understand what it does because there is a good English sentence at the top what it really does. And also there are some test helpers creating some entities, then adding it to somewhere, probably to the database, and then check something. It's really, really readable thing. I care about these kind of tests, and I don't write unit tests anymore. And it can be end-to-end test, it can be functional test, and it can be integration test in the code. It doesn't matter. What matters is it checks behavior, it checks use cases. Why it's great? A quick example. I wrote a small service back then, again, 10 years ago. Oh my God. That was a small caching test, doesn't matter, but because I rushed to write it, I did it at the weekend, and though I did it with TDD, but it was surprising for me that I only wrote API tests to that. I just considered the service a black box and tested all the execution path from the API. And that worked out super well, because throughout the times, in the next 10 years until this service was removed, 2 different teams just rewrote the service. One team just changed the tag behind that, they changed the database behind that, and they barely touched the tests, because the test checked the most important behavior, which was the important thing. And this is why it's great. And now you may ask, why does it matter so much today? Because AI rewrite the code the same time as these 2 teams rewrite my code before. Here is the key. If your tests are glued to the implementation, the agent just rewrites or deletes them to make it green. It games them. If you test the behavior, it's way harder for them to game it, because it's more like a comment to them. It defines a context for these. So usually they do a better job with that. And that's just one thing. The other thing is that these kind of sociable tests do double work. They They are the contract that how the agent must satisfy the task. And also it's a documentation to tell it what correct even means. And why solidarity tests are more noise for agents, because usually it duplicates the implementation tests. These kind of tests are more like a documentation and context for them, which makes their life easier. This is why it's way better. This is why it's not just better for the AI agents, but the humans as well. So we did it back then 10 years ago, 15 years ago, and now it's more important with the AI. Now, we finished with the implementation. We go to the verification, which was one of the largest number from Pharos. It really exploded. Let me show you how to shrink and improve on that a little bit. First, quality gates, automatic quality gates, compilation, linting, type checking, tests, security scans, architecture review or architecture rules via fitness functions, and also AI review. Most of these, or except the last one, all of these are deterministic checks. And these are sensors. They tell you if the system is still safe to move forward. Without them, you cannot really trust that the delivery will be good. But we run all these in localhost, in our machines mainly. Because this is the other, not just because I said that the cloud CI is getting more and more overloaded, but it really speeds up the delivery cycle. And the best example for that is the AI review. We use CodeRabbit at Xund. Sorry, now we are at Xund. So in my current company, we use CodeRabbit as AI reviewer. It normally sits on GitLab, and it comments on every merge request. But when you just push the changes, you have to wait 5 minutes to get some comments. Then you do something with these. Usually you run an agent to fix these, and then push back again 5 minutes and so on and so on. So that's super long. So instead of that, we run CodeRabbit CLI on the local, and you can do it in a loop. So you can easily write an agent which just review the code and then fix it and review again and fix and so on and so on. The most important thing is that you must do it maximum 5 times. 5 is a scientifically proven time or amount of how many times you should run code reviews. Obviously not, but limiting it is very important, because quickly AI reviewers and AI always try to make some work for themselves, always try to prove that they are valuable. So they will find nitpick things, and the fixers will make the code more complex, more abstract, and you need to just somehow overcome this issue. I also write to the AI reviewer, fixer, agent skill set that, okay, if you find that a change would make the code more complex and it doesn't work, then please do not change that part. So with all these, running all these quality gates and AI reviews on local, when we create the pull request, it's almost done. So usually the pipeline shouldn't break on that. Usually people shouldn't find any problems during a code review. And now, it leaves us with the most controversial thing maybe, because what is the slowest thing in verification? This is the human pull request review. Remember the worst numbers from Pharos? It's according to this study. This is because of that review time. The human in the loop is the new bottleneck. And I'm not telling you to stop reviewing. That seemed to be reckless, but I want you to just rethink what you want to do with the pull request reviews, with the reviews. I think a lot of teams throughout the years try to fix their problems with the delivery system by putting more and more stuff into the pull request reviews. Like weak tests, catch it in the reviews. No security checks, catch it in the review. Discrepancies from the coding standards, catch it in the review. That was already too much for a human. Agents just turned up the volume. And honestly, we people, developers are very bad reviewing long merge requests, pull requests, going line by line. we get really tired, we argue about names, and we miss the real risk. And I tell you that anything you catch during a pull request review is something you miss from your harness, from your automations. So it should be done by that. And it's especially important while now you have AI agents to review things, because they can make more abstract reviews than before. And yeah, it's totally up to us, up to you. You can still use human as a gatekeeper, but it won't scale. So it just physically can't scale. So invest in the harness and let the pull request reviews go. We did it at MRSys, so that can work, or make it minimal. At Xund, I said that we have a lot of regulations which we need to comply with. One of that is that every code must be checked by someone. So we have pull requests, but these are really short ones. So usually we don't have long pull request reviews anymore. We just changed that. What we like more, we are in favor of mob code reviews. When every week we just gather and with the team and talk about the most important code and architectural changes, and during these, usually we can find those problems which are not necessary. So usually when someone develops something, it doesn't break anything. It may have a problem from an architectural point of view. These kind of mob code reviews, you can really just talk about that and do something with that. Also, you can improve the harness. But the most important thing is try to squeeze out the human from the loop, and the human should not block the pipeline, because that will slow down the delivery for sure. So, and look what we are left with. So with small changes, with automated gates, with no blocking human review, the changes can now maybe directly flow into the main branch, and we are now at the trunk-based development. This is really the final step, a really great goal for any company to make very small and less risky deployment, because implicitly it will tell you that you have a good enough trustworthy harness. As I said, we adopted it at MRSys many years ago. It worked out well, and now you have a lot of help from the AI. If your harness is trustworthy enough, it will open up a new level on delivery speed. And this is exactly, and which will drastically improve on the Pharos numbers. Stay with me quickly. I will tell a few more stuff here. Just quickly, this is the simplest rule in the whole talk. Now we are at the deploy, and you need to do daily deployment to production. I have a small story here. Once we had a team, and the team started to slow down. Bugs started to appear. Sometimes they could not even make a demo. The team lead reached out to me, told me that he don't really understand the problem. Maybe they have some competency issues and so on. So I dug deep into the team's life, and I found that they had quietly slipped into the bi-weekly deployments. Sometimes they just deployed every 3 weeks. And with that, they silently accepted a few things, like some manual config steps which they needed to make on deployment, some manual verification during deployment, and so on. And during the weeks and months, it just went up to a point where for every deployment, they needed one person, one developer who just oversaw the full deployment for one full day, and that is very bad. So that was really alarming me, and the solution was obviously very stupid. So the team forced themselves to have, again, daily deployment, and because now problems started to really hurt them every day, then now they fixed these. Now they automated that, and after a few weeks, the bugs started to disappear, and they started to deliver better. So what is the moral of the story is that I think daily deployment is really the way to test your harness that is good enough. From the other side, on the day when you cannot deploy, it means that your harness already rotting. Now we are after deployment somewhere. Soon we have a large monorepo. we have a lot of services. Everything is in the monorepo. All are running. If you run all the everything about the CI, so compilation, checks, tests, and so on, it takes around 30 minutes, sometimes more. And what we usually do locally and in the CI is that we only run the affected tests and the affected any kind of quality gate for the affected part of the code. But you need something. We need something which will ensure the integrity of the application. And this is why we have something called periodic check. Periodic check does what I just told you. I just told that it runs everything, all the tests, all the checks, all the automated gates, all study runs, everything which will ensure that the integrity of our whole infrastructure and system is great. We run it every 2 hours, and we will get some information from that. So if it goes red, it means that this is the priority 1 now, so we need to fix that immediately. And because now every new change sits behind the feature flag, it usually doesn't matter if the periodic check broke. I couldn't remember one time when the periodic check was broken and we had our production system down. So that doesn't mean that, but this is still very important from the integrity of the system because that can cause problems later. And here is the best part. That kind of tests usually and jobs usually very faulty. A lot of things can happen with them, but AI is really great to fix these agents. And you can run AI agents locally if the periodic checks are broken, but it's better if you run them in the cloud. So there are cloud managed agents or cursor agents and a lot of different things which can be triggered by a job if it fails and then start fixing it immediately. And what kind of fixes we are talking about? For example, if an acceptance test just broke in the periodic check, usually we don't run these because these are very, very slow tests, and an AI can really fix it quickly. Another typical example is if you have a vulnerability in a third-party library. So this periodic check also checks that, and it can easily update the library and test out all the services which are related. And the best one is flaky tests. So for years, what we did with flaky tests is that we marked them and we set our CI to run it more and more, which made the CI slower, but it worked out. No one wanted to fix these because usually fixing these tests is very slow and boring. But it turned out that AI is really great on that. So you can really have some AI agents which can just quickly do that. They never tire. They can run it 1,000 times and ensure that there is no problem with dev. So all these boring and frustrating jobs, you can really just put it to the AI and you can focus on the development side. So with these, we make the whole cycle green. We can shrink the lead time. But I wanted to tell you one more thing, because using feature flags and because splitting deploy and release, it opened up my favorite continuous delivery practice called dark launch. Dark launch is about that you run a new code in real production with real traffic, but without the user seeing that. My best example is at Imos's time, once we needed to rewrite the email rendering, which, as I mentioned, we rendered millions of emails every day. It was really scary. It was really old. It was really legacy. No one wanted to touch that, even the mail sending team. So that was a very risky project. So what we did is that we started to build up the new shiny rendering engine next to the old one, and we just run it along with the old. But at the end, when it generated the email, we didn't send it out. It went to the trash. But we had a point where we could compare the two emails, so with the old and with the new one. And by that, from day 0, we could really see how see the coverage of the new feature of the features, how much we cover the old features, and so on. And also, that is a really great practice to have a good performance test, because you cannot really fake a real
real performance issues, real peaks on your systems. But with that, you can, because the new system will get the very same load what the old system does. So you will have insights on that, and you can also do something with this. Okay. So what to take from this talk? AI did not kill continuous delivery. It raised the cost of not having a harness, and it lowered the cost of building one. Do continuous delivery, but let the AI run the discipline. It can work in small batches, it can clean the flags, it can fix flaky tests, it can find out what broke the build. And it's really important to stop pretending that the human inspection will scale. Stop pretending that giant pull requests is reviewable. Stop pretending that looks good to me kind of PR reviews are protection. Stop pretending that deployment is a pain. It's not. It's a feedback telling you that your harness is missing. Do not scale human oversight. Remove the human from the loop. Scale your harness. Thank you very much.